think, well, 27 is 3 raised to what power? So in this case, the problem gave me the base, it gave me the exponent's value, and now I just need to think of how many times would so what I'm thinking is, how many times would I multiply 3 by 3 to get to 27? Partway is a trial and error. 3 times 3, okay, that's only 9. That's not enough. So maybe I have to do another times 3. So 9 times 3, oh, that's 27. How many did I have? 1, 2, 3 of them. Not my favorite, where the base and the exponent are the same number. It's coincidence. But 3 cubed is 27. So there's that one. Then they have another trickier one where they have a fraction and they want to know, they've given me again the base, the problem, they that wrote the math book have given me the base, and once again I'm trying to figure out what that exponent is. Now again, notice the parentheses is around the whole thing. The good thing here is that however times I multiply 8, I should also multiply however many times. So now I'm thinking about it. So now I've got a different problem I'm thinking about. I'm thinking about how many times am I going to multiply 8 to make 64? And at the same time, how many times do I multiply 9 by itself to get to 81? The good news is it better be the same number. So I have a way to check my work, and I can do the easier number. So I have an option. I have one way to go an easier number, and then I can go from there. 9 times what? What is 9 times 9? Out there, just checking. Not sure, I could be looking at a multiplication. I could be trying it into my calculator. 9 times 9 is what? 9 times 9 happens to be 81. So now I'm hoping to check that. 8 times 8 should be 64, is it? It is. So both times, I only had to multiply it twice, and it should match both times. So that's 8/9 to the second power. I took 8/9 times 8/9, I should get 64/81. So
Will it always be like that for square roots? Looking at those numbers, what? Because 8 is the square root of 64 and 9 is the square root. So if it's squared,
it's the square root, actually, that's the symbol that you'll see next year, and it's on your calculator. It does undo the second power. And then there's this symbol, the cubed root will also take it for the third power. And both of those, remember I showed you on the calculator. If I pull the
people weren't here yesterday, so this is a good trick. Look at this, people. Did anybody know this was on here?
Your regular calculator, and if I turn it sideways, 81, and if I hit that button that has the square root, and I have to find it first, it's got to be on.
I love that. I had no idea that was on there.
There's a square root. Well, they even put the 2 there. This is another invisible thing. On the calculator, it puts the 2 there, but in math, if there's no 2, it's assumed it's the second power. So if I take 81 and I hit that square root, it gives me what times itself, one time, would make 81. So that's a way.
Yeah, and square roots are only whole numbers if it's that square number. Otherwise, most numbers have square roots that are decimals.
And that's it. But that square root is coming, and that's what they mean by the root. This is a root, right? Like a root word. So math is so much related to language. What's a root word? Something that you add a prefix and a suffix to. What's a root in math? Something I'm multiplying or adding to. In this case, I'm multiplying again. So the square root would be the root that I would square to get the other. So the square root of this number is 8/9. So just a little extra coming down. Another
square go over the left part or the right part?
this is how I would change the problem to make it true. The square root of this would be 8/9.
Got it. Thank you.
That's coming, like, I think next year. Talking about that a little bit more. All right, the other kind of problem, I like this kind. I got it, I just have to count them. I don't mind this one, it's a little trial and error, okay? Times another root, another factor in, I'm okay, one more time. This one, I'm gonna tell you, is the hardest thing for me, unless I can use the calculator and they don't want you to. Thinking about something, and maybe I'll start with an easier one because that looked a little bit.
Oh, do it.
All right. Oh, I'm gonna need help then.
We'll do it. We can do it together.
This is the hard.
Smart group. They just have to unmic and talk to you. Where are you people?
This is the hardest kind of problem because I have the big number. I don't know what the base is, but I do know that I have to multiply it by 4 times. So what this question is really asking me to think about, can you still see, or my?
Yep, you're good.
What I really have to think about is 256 is some number multiplied by itself 4 times, and I'll get 256. So I have to think about that. And then in algebra, if I were writing it, I wouldn't put the box in, but I would put the same letter. I would have A here to show that these are all the same number. Yes, they're all blanks, but they're all the same number. So trial and error, not my favorite because it takes so much time. I could think of, well, what if I put a 2 in here? 2 times 2, so I have to think of, okay, well, what's 2 times 2 times 2 times 2? 2 times 2 is?
4.
Times 2 again makes?
8.
Times 2 again?
16.
Only 16. I've got a long way to get to 256. I need to step it up.
With
So
16 times 4, that would be 24.
I try 4, Mrs. Nelson? Is that what you're saying? Because I don't think I'm going to do 3. 16 is 4.
I'm just trying to think of a number now that will give me, when I multiply it, a 6 in that units position. So, like,
It would be
It would be what?
times 8.
Let me try 8. Okay, so
I was looking at that 64 above too. So 64 times 6, 4 times 4 is going to get me a 6 in the units position. So it could be a 4, but 4 is not going to be big enough. So maybe 8.
times 8 is what?
64.
Times 8 again. And again, trial and so 4 times 8 gives me 512. I've overshot. Okay, so this is already, I've already got to 512. 64 times 8, I'm gonna double check, 64 times 8, I haven't even done it the 3rd time. So my number between 2 and 8.
So 8 was too big?
Too big, too small, so this is why we're using trial and error. Got to come in between. So what should I try? Should I try 4? Should I try 6? I know it's not going to be 5 because 5 always ends in 0 or 5. So I know it's, so
It's 4.
4, 5, 6.
It'll get me 36 in the end, but I don't know.
4.
Somebody said 6 is too big.
All right, let's try 4. So 4 times 4 times 4 times 4. 4 times 4 is 16.
16 times 16.
Okay, all right, yeah, I can do that. 16, and then it's another 16.
63.
Times 16. Do it on paper.
10 times 10 is 100.
That is it.
Is it?
The one. That's the winner. Oh, so it wasn't.
Oh,
Almost messed it up.
yeah.
4 raised to the 4th power is 256. So this is a little bit harder because the trial and error takes me a little bit long. I go a little low, I go a little high, I shoot around. one thing I like to do when I am doing trial and error is pick a number like 5. 5s are easy for me to do. I can pick a number like 5 pretty quickly and get that done.
256 is a good one to memorize, though.
It is, and that was a familiar number to me, and now I know why. I was like, I have a connection with that number. I couldn't tell you what it was. It's been a long time.
It's like 3 to the second power is going to be what? Everybody, what's 3 to the second power?
27.
What is it?
27.
3 to the second power is 9. 3 to the third power is 27. What's 3 to the fourth power? 3 to the fourth.
71.
81. 81.
I don't know. Are you saying it as a question or are you saying it as an answer? Don't guess.
81.
Okay, so 81. 81 can be written a lot of different ways, right? 3 to the fourth. Are you saying 3 to the fourth is 81? 9 to the second.
9 to the second.
3 to the
Yeah.
fourth. There are lots of different ways that we can write the number 81. All right, so there's a pattern there.
Always looking for patterns. It helps you make connections. It's helping you think about different things.
When we're looking at 81, I can write 81 as 9 to the second power, but that's not prime. So tomorrow's lesson is prime factorization. That's not a prime number. So now I have to look at 9. And how can I write 9 as a prime number? 9 as a prime number would be what? What are our prime numbers? Yeah. So now we have 3 to the fourth power, which is above that. So looking at our vocabulary in this session, like really prime numbers we need to know when we're doing prime factorization. So 81 can be written 9 to the second power, but it can also be written in prime factorization form, which would be 3 to the fourth. Good one to memorize. 3 to the fourth power is a good one to memorize.
Definitely comes up quite a bit. Knowing what 3, well, knowing your 2, your 3, your 4, and your 5. Knowing those 4 numbers to the second power, to the third power, it comes up a lot. A lot. Especially the second and third powers of those numbers. They come up quite a bit.
And that is a lesson on
Exponents.
Exponents and kind of why they're important and why scientists and mathematicians use them a lot. Remember, they are a way of writing shorthand and also a way of looking at numbers and factoring them out, which allows us to solve algebraic expressions.